This is video 2.5.2, and the goal here is to be able to find the number of factors of a polynomial and write a polynomial from a situation. So we're actually going to write the rule based on some information we're given. So here's some interesting things that are nice to know. So Descartes' rule of signs. This is going to help us eliminate some potential roots, some potential zeros that we're going to test because of something that this gentleman, Descartes, figured out years ago. So it's going to help us determine the number of positive and negative zeros in a polynomial. So it's going to tell me how many there exist, and so that way I don't guess the wrong things that don't actually exist. So the first step is to count the number of sign changes for f of x and f of negative x. Okay? So when we talk about sign changes, we're looking for things that are positive or negative. So we're switching from the plus to the minus, and we're going back and forth. So if we look down below for f of x, we see 0 sign changes because it's all positive quantities down there. So because there are 0 sign changes, we look at step 2 here, and we see that that means there are no positive roots. So that means when I make my list of potential roots, and I usually look at the coefficients of the final and the highest degree, I would have made my list originally as positive or negative 1, 2, and 4. But now, based on Descartes' rules of signs, I can see that there are going to be 0 positive roots. So that means my list has changed. Instead of positive or negative 1, 2, and 4, it's only negative 1, 2, and 4. So I've essentially eliminated all positive numbers based on Descartes' rule of signs. So looking at the sign changes for f of x, now we look at the sign changes for f of negative x. So what this means is I'm going to plug in negative x everywhere that I see x in the quantity. So I'm going to do negative x to the third, 2 times negative x squared, plus 5 times negative x, plus 4. And I'm going to simplify a little bit using what I know about negatives. So f of negative x will be, let's see, negative x to the third plus 2x squared. So remember, when you ever square a negative, it stays positive. It turns it positive, excuse me. And then minus 5x, and then plus 4. So I just simplified using what I know about negatives. Now I look for sign changes. So it starts negative, that's just where it starts, and it changes once. So here's one change. So now it's positive, but notice it changes again. So here's a second change. And then again, it went from negative to positive, so here's my third change. So now, looking again at Descartes' rule of signs, so this tells me the number of negative roots. So now, because I got the number 3, that tells me there are up to 3 negative roots. Okay, but looking at the rest of that sentence for number 2, the number of zeros is the number of sign changes or less that number by a positive even integer. So that means there's either 3 negative roots or less that number by a positive even integer. So it could be 3 minus 2 negative roots because I'm taking that number and I'm lessing it by a positive even integer, 2. So that means that there could only be, maybe there's 3 negative roots, or there's only 1 negative root, or there are negative 1 negative roots. That doesn't make any sense. So it's going to be either 3 or 1. So the trick is that I know that there's at least 1, so I'm going to test all of these potential roots, and I'm going to see which one it is. And then I'm going to see if there's actually 3 or 1 negative roots. But in this case, there's 0 positive roots, apparently. So that's how Descartes' rule of sign is nice, because it eliminates roots. It also kind of narrows in on what I'm looking for, so I don't kind of just willy-nilly try everything. Okay, it's going to help you focus your energy on trying the things that matter. So now we're on to our second part of our objective. The goal of this objective is to be able to write a polynomial equation. And we're going to use these 2 facts that are listed here about these properties of polynomial equations. If its degree is n, then it has n roots. Okay? If its degree is n, then it has n roots. And we've already kind of talked about this. So remember, if the degree is n, that means like in the polynomial f of x equals x to the 5th plus x squared plus 2. The degree here is 5. because remember that's the highest power. The highest power is your degree. So that means there are 5 roots. But the quick note that we need to see here is that some roots may appear multiple of times. So if something appears 2 times, that counts as 2 roots. So it's kind of like we're saying we can factor it into 5 things, but they might be similar. They might be the same root twice. Okay, that way we know we've hit all 5. So when we're writing a rule or we're trying to factor, we want to make sure we have the right number of roots based on the degree. The second fact that's good to know is the following about imaginary roots. So if a plus bi is a root, then so is a minus bi. So they come in pairs. They come in conjugate pairs. When we're looking at roots, so we're talking about imaginary and real roots. When we have imaginary roots, they come in pairs. So if there's one, then there's definitely a second. Okay? So what we're going to take here is use these 2 facts to help us write a rule. So first of all, it's a 4th degree polynomial. So 4 degrees means that my polynomial will have 4 roots. So I'm going to start with my 4 pairs of parentheses to denote my 4 roots. Now it tells me, it also tells me it has real coefficients. Okay, that's important because it's going to be a real polynomial, not an imaginary one. And it has -2, 2, and I as zeros. So those are the roots. Remember, zeros and roots are synonymous. So that means that one of my factors is x plus 2, because that would give me the root of -2. The other factor is x minus 2, again, because that would give me the factor of the root, the 0 of 2. So I've used these 2 pieces of information, and it has I as a 0, so that means x minus I, because if I were plugged in, I would get a 0. So now we're missing the 4th root. So we need all 4. The 4th root is the conjugate of I, positive I in this case. Since this is like 0 plus I, my conjugate is 0 minus I. Okay? The I term should be opposite. So it looks like my other root is x plus I, because that would give me negative I. So we're using the second property up there to help us find that 4th root. So we used 4 pieces of information. The last piece of information is crucial. Many people forget this piece of information. There may or may not be an a value that's out in front here, a factor that doesn't have x in it, that doesn't affect the roots or the zeros, but definitely stretches the graph. So this is our stretch factor that we're going to see coming up a lot, and always it's the last thing you usually find depending on the information given. So what we're going to start with is we've got our roots, but we're going to first simplify this out a little bit. First of all, we don't like to put imaginary numbers in answers, so we're going to multiply that out. We're going to leave everything else factored, and we're going to multiply this out. Since it is conjugates, I know I'm going to be only left with my first term and my last term. Sorry, minus I squared, of course. Now, the inner and the outer, if you're not convinced, do them. Inner and outer of FOIL. It'll create a negative IX and a positive IX, which ends up canceling. The whole point of conjugates is that they cancel. So I know that negative I squared, well, I squared is -1. And when I take x minus -1, I get x squared plus 1. So my resulting polynomial is going to be x plus 2, x minus 2, x squared plus 1. So now I have it all real numbers, no imaginaries are left, and I have a polynomial here to describe the situation so far. Sorry, my plus 1 there is looking a little shabby. So now I need to figure out this a value that I talked about up here, so that when I plug in 3, I get -150. So I'm going to put 3 in for x, and I'm going to figure out if y is -150, or what a I need to find for that to happen. So f of 3 is a, 3 plus 2, 3 minus 2, 3 squared plus 1. So let's see what this gives me so far. I'm looking for -150. A times 5 times 1 times 10. So it looks like I don't get 150, I get 50 A's. Okay, because this multiplies out to 50. So what does A have to be in order to make this work? Well, divide both sides by 50, and we'll see that A should be negative 3. So my polynomial that I had up in blue there was good, but the answer is in fact negative 3 times x plus 2 times x minus 2 times x squared plus 1. That's the polynomial they were asking for. So finding the roots and setting it up with your factors is the first step, and then you do have to plug in that number to make sure you don't have a stretch factor, because that does not affect your zeros. All those zeros will still work, and the 3 will also work. So that's kind of your video for today. The goal here is to try and use it for number 1. Okay, so using Descartes' rule of signs, determine the number of positive and negative real roots of the polynomial, then list all possible real roots. So after using that information, list all the remaining positive real roots. So if it so happens that all the negatives are eliminated, then eliminate the negatives. Okay, but describe what will happen, how many positive and negative real roots are possible for this polynomial. Then your second goal is to write a rule in second question for a 5th degree polynomial with the following roots, whose graph bounces off the x-axis at x equals 3, and f of 2 is negative 5. So I'm looking for you to get a start on both these problems. So try and apply Descartes' rule of signs and try to start the rule for number 2 and bring your questions into class.